This is simply about networking protocols, and today I'll talk to you about ECN. Standard that describes ECN as is 3168. You can find additional standards that describe an ECN functionality in additional conditions, corner cases, and so on. You will find depending on what exactly you need to implement or verify. And ECN is tightly connected to AQM, so AQM standard is 7567. In this video, I'll remind you what is congestion. We will talk about why we need ECN at all, how a router processes ECN, what host does when ECN process comes in, AQM and queues management, AQM and ECN, how they tied, ECN in IP packet, and some specific related to ECN and mixed IP and non-IP traffic. I'm sure you remember from video about PFC what is congestion, but let's remind. So we have traffic that passing our device, our router, without problems, happily, no any issues. Then for any reason, amount of traffic that needs to be transmitted through our device from specific port increases for any reason, doesn't matter. Increases, and at some point, amount of traffic that expected to be transmitted from some port reaches physical ability of port to transmit, reaches line rate. And at some point again, we're receiving even more traffic to be transmitted from this egress port, and this causes that egress buffer overloaded. We attempting to transmit more traffic than we physically can transmit. It causes packet loss because packets being lost due to buffer overload, or management tools, protocols, and functions step in and start dropping traffic according to our configuration. Doesn't matter. We're losing packets, we're losing frames. So this situation where when we try to transmit more than physically can from specific port is called congestion. So what is congestion, where it is in scope of router? Imagine we have some network with multiple routers and we are transmitting traffic from sender to receiver happily, no problems, traffic is running, no any loss or whatever. And at some point through one specific router, maybe several, but in this case through one specific router, one specific port on this router, we're trying to transmit more and more traffic for whatever reason. Flow burst, traffic burst, more transmission requirements and more flows come in. Doesn't matter. So the more and more traffic we're trying to transmit from one specific port, and at some point, and on this port appears congestion condition. We're trying to transmit more than port physically can transmit to next participant. What happens? We start losing packets, frames, and from receiver point of view, it doesn't care about all other packets and frames. It cares only about frames from our flow that being lost, dropped, and so on. So we have some rate at which this flow is being transmitted from transmitter to receiver. Receiver receives less. Okay, receiver doesn't know how many packets per second transmits transmitter. Okay, but in case of IP traffic, receiver and probably application that require this traffic stop seeing that frames are lost. Those frames that are dropped due to congestion on this interface. But still, our receiver has no clue what's going on. We just see that traffic is being lost. It can be lost because something happens here. It can be lost that something happens in the network. So just observing the problem itself. And here is ECN steps in. Our router, in condition of congestion, can update frames, IP frames that being sent to our receiver with ECN information. This ECN information reaches our receiver. Receiver understands that there is congestion on the path. And then, if receiver and transmitter supports ECN, they start communicating in scope to reduce somehow the traffic, to reduce or bring to zero all losses. They are communicating back using TCP protocol with ECN information, but this ECN information is out of scope of this video. This is host-related ECN. Those hosts supposed to support ECN, okay? You can find this information in the ECN standard, but not in this video. So they start communicating, informing receiver informs transmitter that there is a congestion on the path, and transmitter, if supports ECN, can reduce the amount of packets sent per second in order to reduce or bring to zero loss that we observe. And if everything is configured right, everybody supports ECN, and ECN works as expected, our traffic between transmitter and receiver again working happily as previously. Let's take a closer look on our router and what's going on. So, AQM, Advanced Queue Management. We have this transmitter egress port with multiple queues. Again, probably you remember from PFC or from other previous videos that we can configure multiple features like quality of service, like some additional protocols, functions, and features in order to manage. Would we lost this traffic? Would we send pause frames? Would we do something or we do not do something? AQM requires our ability to configure potential port with port where potentially high load available, to manage size of queues and things like that. So, but main idea here is this. We have already some queues. We have frames in those queues. Those frames being selected and sent out. In case we are reaching end of the queue for some specific queue, then IP frame that needs to be sent by IQM is being updated with ECN. So, okay, AQM signals that queue almost reached, almost full, and the system, if system supports ECN, updates, transmit IP packets from this queue with ECN information. Those packets are being sent to receiver. In case multiple queues reaching their buffer size, IP packets from those queues, IP packets from those queues being updated with ECN information if system support this. And even when we started dropping packets in the queue, some specific, still transmitted packets being updated with ECN information. The main idea is to start this ECN communication before packets being updated, when we close to this congestion condition at all. So our end devices can communicate to each other and prevent this situation. So what is ECN information? Very simple. In scope of router and IP packets, in an IP header in DSCP section, there are 2 bits that having this ECN information. If both bits are 0, this is no ACT. It means that end devices, hosts, do not support ECN. No need to update those packets with ECN information, because hosts will not react to it. They can be dropped. But if we have 01 or 01 or 10, it means that those devices support ECN, and they can react to ECN information. Okay? Then, if congestion is close and AQM signals that ECN needs to be used, those fields are updated to 11, those bits. And this information being sent to receiver get this signal, understands, send it back, initiates TCP communication related to ECN, but this is host related ECN, out of scope of this video. Okay, so that's very simple in scope of router, but you already understand, right? So in case we have mixed traffic where we have IP packets and non-IP packets, and queue is close to be full, overloaded, and IP packets are not being sent yet. Drop started, IP packets not being sent yet, no ECN information can be sent. So at some point, this is pretty short period of time, but we will have IP packets drops, probably, without sending ECN information, even if AQM, ECN, and device overall configured properly. So the main idea of this thing is to avoid on router or maybe on router interface, on router port situation when IP and non-IP traffic being mixed in order to provide better ECN service. That's how simple ECN and routers are working with each other. Thank you. Have a great day.